Good day, everyone. Welcome to the Part 3 video episode for Lesson 2 Physical Properties of Solutions, Solution Stoichiometry. Solution stoichiometry involves problems that incorporate concentration. It is important that correct conversions are observed. Thus, labeling units used is a must for reactions that take place in solutions. Sample problem number 1. Nitric acid reacts with sodium hydroxide in solution to give sodium nitrate and water. How many moles of water are formed when 25.0 ml of 0.100 molars HNO3 completely reacts with sodium hydroxide? Here is the equation. Nitric acid plus sodium hydroxide forms sodium nitrate plus water. We have AQ symbol here. AQ stands for aqueous solution. Aqueous solution contains water as the solvent. And then we have L. It stands for liquid. Model and solving solution stoichiometry. We have quantity A, 2 mole A, 2 mole V, 2 quantity B. Step 1. Identify the given information of what the problem is asking you to find. So, how many moles of water, that is what is being asked? And the given 25.0 ml of 0.100 molars HNO3. And of course, the molarity is 0.100 of HNO3. So that these are our given. The molarity, remember from our previous lesson, is equal to mole per liter. So we can write this molarity into 0.100 mole HNO3 per 1 liter of HNO3 solution. And another given is 25.0 ml of HNO3. And required is mole of water. This molarity, remember, that we can reverse depending on what we need to cancel out. So this can also be equal to 1 liter HNO3 solution over 0.100 mole HNO3. Formula. The same with the model. Solution. Set up and balance the chemical equation. If the equation is already balanced, proceed to the next step. Recall our previous lesson in balancing. So check. The equation is already balanced. We do not need to write coefficient or coefficients. And remember that if there are no coefficients written before the formula of the compound, it is understood as 1 mole. Okay? 1 mole. So we can read the equation as 1 mole of nitric acid plus 1 mole of sodium hydroxide will form 1 mole of sodium nitrate and 1 mole of water. Relate the situation to the model earlier presented. Okay. Quantity A, 2 mole A, 2 mole B, to quantity B. So, quantity A from the given 25.0 ml nitric acid. ml is quantity. We convert the ml to liters by getting that conversion of 1 liter is equal to 1000 ml. Then let's go to the mole. This is now the molarity of the solution. 0.100 mole HNO3 in 1 liter HNO3 solution times mole B. So, mole of B, the water here, would be taken from this equation. 1 mole of water is formed per 1 mole of nitric acid used in the reaction. So, 1 mole water over 1 mole HNO3. Class, remember that we arrange it this way so that we can cancel out mole HNO3, and what is left is mole water in the numerator, which is what is the required. So, we have to cancel mlHNO3. This is liter HNO3, mole HNO3. What is left is mole water, which is being required or asked in the problem. So how did we get this answer? 25.0 times 0.100 divided by 1000 is equal to this value. Next. Sample problem number 2. What volume of a 0.470 molars HCl reacted with enough zinc metal to produce 1.50 grams zinc chloride based on the following reaction? Zinc solid plus HCl aqueous will form 6 zinc chloride aqueous plus H2 gas, or this is hydrogen gas. Balancing the equation. So we need to write coefficient 2 here to balance the equation. Step 1, given 1.50 grams zinc chloride, that is the mass of zinc chloride, 0.470 m HCl, that is the molarity of HCl. Required volume, what volume? Of 0.47 molar HCl. Formula the same. Solution. We have to rewrite the molarity to 0.470 mole HCl per 1 liter of HCl solution. And then we have to solve for the molar mass of zinc chloride. So zinc 1, chlorine 2. Zinc has an atomic mass of 65 and chlorine has 35. 65 plus 70, 135 grams per 1 mole. This is the value when the atomic masses are rounded off. And this is the value when the atomic masses are not rounded off. Okay. So there is 1 zinc and there are 2 chlorine. Okay. So that is the value. So either of the two will give you the same answer in this problem. Okay. And then this is the solution. And this is the model that we have to follow. So quantity A, 1.50 grams zinc chloride times, we convert the grams or the quantity to mole by using the molar mass. So 1 mole of zinc chloride has 135 grams of zinc chloride times mole B. 1 mole of zinc chloride per 2 moles of hydrogen chloride. So 2 moles of hydrogen chloride will react to form 1 mole of zinc chloride. Okay? So arrange this mole ratio depending on what you need to cancel out. So we have here mole zinc chloride. We need to cancel it out. So we put the mole zinc chloride at the denominator. Then next, we have mole B in 1 liter of solution of HCl. There are 0.470 mole of HCl. This is the molarity. So mole HCl cancelled out. What is left is liter. So the answer is equal to 0.0104 liter or 10.4 ml of 0.470 molars HCl. Sample problem number 3. How many grams of calcium hydroxide are needed to neutralize 25.0 ml of 0.100 molars nitric acid? The reaction proceeds as follows. Nitric acid plus calcium hydroxide will form water plus calcium nitrate. Calcium hydroxide here is solid with the symbol of S. Given 0.100 molars HNO3, which is also equal to 0.100 moles HNO3 in liter of HNO3, or 0.100 mole HNO3 in 1000 ml HNO3. This is 1000 ml, which is equal to 1 liter. Volume of HNO3 is equal to 25.0 ml. Required mass in grams of calcium hydroxide. Formula, the same formula. Solution, balance the equation. So by adding 2 as the coefficient for nitric acid, we already balanced the equation. So the same, 2 moles of nitric acid plus 1 mole of calcium hydroxide will form 1 mole of water and 1 mole of calcium nitrate. So quantity A, 25 ml HNO3 times the molarity, 0.100 mole HNO3 in 1000 ml HNO3 times mole B, 1 mole calcium. Where did we get this mole of calcium hydroxide? 2 moles of HNO3. Here, 2 moles of nitric acid will react with 1 mole of calcium hydroxide. Okay, so mole of HNO3 here is in the numerator. We need the 2 moles HNO3 in the denominator to cancel out. Times 74.08 grams calcium hydroxide in 1 mole of calcium hydroxide. This is the molar mass of calcium hydroxide. So the mass of calcium hydroxide now, okay, before that, this is MlHNO3 cancelled, MlHNO3, and then we have mole HNO3, mole HNO3, calcium, mole calcium hydroxide, mole calcium hydroxide. What is left is grams of calcium hydroxide. Grams of calcium hydroxide is also equal to the mass of calcium hydroxide, which is equal to 9.09 grams of calcium hydroxide. Again, how do we get this 0.09 grams calcium hydroxide? 25 times 0.0 times 0.10 times 74.08 divided by 1000 times 2. The answer is 0.09 grams of calcium hydroxide. Okay, so this is the one from your module. It's just the same. So here 25 times 1.010 divided over 1000 ml. Then this is the answer, times 1 mole calcium hydroxide, 2 moles nitric acid times 74.08 grams of calcium hydroxide over 1 mole of calcium hydroxide. It is the same. Okay. This is the last video for self-learning package, Quarter 1, Week 3, Physical Properties of Solutions. Thank you for watching. If you learned something from this video, please like and subscribe to my YouTube channel. God bless and stay safe, everyone.